Hi, welcome to our Chapter 5 review. We're talking about probability in this video, so don't forget to pause, read, blah, blah, blah. And of course, kitties are awesome. 15-minute timer, instructions on our Frappy. Don't forget to pause and read through every video, every slide before you begin working through these questions yourself. Here's slide A, slide B, slide C, slide D. Alrighty, so solutions are coming. Don't forget to practice these questions on your own. You can look up the PDF in the assignment tab. A statistics teacher has 40 students in his class. 23 are female, 17 are male. At the beginning of class on Monday, the teacher planned to spend time reviewing an assignment due that day. Unfortunately, the teacher only had 19 of the females and 11 of the males complete the assignment. The teacher plans to randomly select students to do problems from the assignment on the whiteboard. Question A. What is the probability that a randomly selected student has completed the assignment? So we're going to jump on into probability calculations. The first thing I did was organize the information into a two-way table. So here's that two-way table. To get my probability, what we're looking for, that any student selected has completed the assignment, the thing I do is I go for completed assignment and I look for that total, or I add it up myself. So the total of kids who have completed the assignment over the total number of students would be the probability of completion. So 0.75 probability, or 75% chance the student completed the assignment if I randomly select from my 40. Moving on to question B. If you need practice on probability two-way tables and Venn diagrams, you can go here. Question B, are the events selecting a female and selecting a student who completed the assignment independent? So here we're dealing with independence and dependence. This is going to be, we're going to go back and forth between two major chapters in Khan, and that's the probability chapter and the random variables chapter. So let's jump on in. Just a reminder about independence. You can actually calculate independence if you take the conditional probability and you set it equal to the independent probability. So if I take the condition of the probability of B given A, that must be equal to the probability of B. Vice versa, if I want to find the probability of A given B, that must be equal to the probability of A. For those independent events, so two events to actually be claimed as independent. If they are not, then we don't have independent events, and we can describe it as such. And so let's look at that calculation. So for ours, our P of B is going to be students who have completed the assignment, and P of A is going to be female students. So I went ahead and set this up for us. I set it up now in language we understand. The P of B is the completed, so this is going to be the probability of completed assignments given that they are female students. That's how we read that sentence. But then I have to remind myself that there's a little bit of formula behind this. The probability of, conditional probability has a formula given by the probability of the union over the probability of the denominator. So if I want to find the conditional probability of P of B given A, then I find their joint probability up top and divide by that denominator, that P of A information. So let's go ahead and solve that out for ourselves. So the probability of the joint where B and A occur would be, so B and A occurring would be completed assignments and females, right? Okay, actually, let's just circle that. Why not? So completed assignments and female. And look at that. We end up with our numerator value 19. So the union value where B and A are intersecting is 19, but it's still over 40, the total number of students in the class. The denominator, just the probability of A, remember that was just our female students, would just be this 23 out of the total 40. So I end up with this fraction down here, 19 over 40 divided by 23 over 40. I do fraction mathematics, and I end up with just the probability of 19 over 23. So we end up with a conditional probability, P of B given A, is equal to 19/23. And remember, we're solving this to be equal to this. Probability of just B, the completed assignments we did in question A. And so that was 30 out of 40. Are these two statements equal? No. So they are not independent. There's a train going by. He's a little loud. Sorry about that. Hopefully you can't hear it too much. But to answer our question, the question said, are the events selecting a female and student who completed the assignment independent? Sorry, I want to make sure we were answering the right question. Are they independent? The answer is no, because those two calculations don't equal each other. So here's our justification. No, because our conditional probability of P of completed assignments given female is 19 out of 23, is not equal to the P of just the completed assignments, which was 0.75, 30 out of 40. Little justification further, or inference further, would be knowing that a student is female actually increases the probability that the assignment was complete. And we can go ahead and just look at those conditional probabilities and we'll compare. 82 or 83% compared to 75% means that if they were a female, they had a higher chance of completing the assignment according to this table. It's not giving you any further information than that. It's not saying if you're a female, you have a higher chance of completing the assignment, like just because your gender is female, not necessarily, but in this classroom, if he randomly selected a student, if he randomly selected the student and the student was female, there was a higher chance the assignment was complete. So remember to read that information based off of the givens, and you can't infer further unless you're allowed to infer further. Here we've got two different sets of practice. If you just want to practice independence, this is the practice for you. If you want to practice conditional probability, which is most of what I just did, then this is the practice for you, or both. The C and D talk about a brand new topic. So there's this new paragraph I'm going to read out. Suppose that the teacher randomly selects 4 students to do a problem on the whiteboard and only 2 of the students had completed the assignment. Cool. Describe how to use the table of random digits to estimate the probability that 2 or fewer of the 4 randomly selected students completed the assignment. Great. So we're going to use that table of random digits, and there's a QR code for a page if you're like, I still don't get the table of random digits. It's coming up in just a second, so just be aware of that. So all they want is a descriptor. So I'm just going to read out the answer because this is literally just set up a assignment problem with table of random digits. That's literally all it's saying. So I've got 40 total students, and I'm dealing with all those numbers, 19, 17, 23, and 11. And then we've got to deal with the selecting 4 and only 2 have completed the assignment. So we're going to go ahead and assign the numbers, just random numbers. 0, 1 to 30 has completed the assignments. I could have done 0, 0 to 29. That's fine as long as you remember that the number 0 is a value. Okay, so from 1 to 30, those are completed. From 31 to 40, didn't complete. Cool, that's my classroom ready to go. If I go to the table of random digits, then how do I read? So I'm going to go ahead and skip numbers 0s and numbers 41 through 99 because all those values are seen on the table of random digits. Remember, the table of random digits has a bunch of typically 2-digit values or 3 or however many you're using because it's a table of random digits, but remember to assign that for yourself. So if I'm dealing with 2-digit numbers, 0, 1 to 30, 31 to 40, then I have to think of all the 2-digit numbers and account for it. So that's what this magic sentence is talking about right here. Skip 0, 0, and 41 through 99. They're just reminding you of the numbers that don't matter to us. Going left to right on the random table, I'm going to choose 4 different 2-digit numbers. Why am I picking 4 different? Because we're randomly selecting 4 students. So I pick 4 different 2-digit numbers. So if I'm reading left to right, okay, here's a 2-digit number, here's a 2-digit. We're going to see this in just a second, so don't stress too much. Count the number of students among the 4 chosen who have completed the assignment. Count how many of the numbers are 1 through 30. Repeat this process many times. This is an important statement because if you're not repeating this process many times, then are you really creating a design experiment? Just estimate the probability that 2 or fewer students completed the assignment. Divide the number of trials where 2 or fewer completed the assignment by the total number of trials. Seems like a lot of work, but really, if you think this through, they're just in a paragraph, they're setting up how you would have walked this through. So let's walk it through because guess what question D wants us to do? Complete 3 repetitions of the simulation. Going back really quickly, if you're still struggling with random table, because I know that's hard, here's a visualization and a little web page about how to use the table of random digits. And of course, you can Google it for yourself, or you can just see this video slide where I'm going to go ahead and do that for you. So completing 3 repetitions, and that's the number of trials that they want us to do, we're going to do using this part of the table of random digits. So if you notice, something funky would happen. Okay, 2-digit numbers that represent students are underlined. So that means I started on the left and I went, okay, that's a 2-digit number. We can use the number 12. Why did I say the number 97 doesn't work? Well, because we are ignoring the number 0 and then 41 through 99. So I can't even use this number. That's what they're telling us. If it's annotated with a Y, that means they were the numbers 0, 1 through 30. That meant completed, right? If it's annotated with a no, that means they're number 31 through 40. They didn't complete. If it's numbers 0, 0, or 41 through 99, they're going to have a cross out. I'm going to make it even easier, and I'm going to cross them out with my red. Now, this might be a slightly longer video because I really am trying to show you that table D value. And I want you to notice as I went along, there's something I should have noticed. There's the table of random digits is set up in 5 segments. And the reason they do this is to make it easy for you to see. It has nothing to do with those 5 numbers belong to each other. No. It has everything to do with just making it visually pleasing for you. So as I go through the number 1, 2, there's my first digit number. Number 9, 7, I don't like it. The next number isn't 5, it's 51. I can ignore that space, okay? So I don't want that number. The next number is 32. If I remind myself what my values that matter are, 30, 31 through 40. Okay, so 12 is a yes, 32 is a no, 58 we cross out. 13 is a yes, 4 is a yes, 84 is a cross out, 51 is a cross out, 44 is a cross out, 72 is a cross out, 32 is a no, 18 is a yes, 19 is a yes, 40 is a no. Don't know why I put that on there. And 0, 0 is a cross out, 30, so on and so forth. How do I know I've completed a trial? Well, remember, we're selecting 4 students. So here's student 1, 2, 3, 4. So we put a giant vertical bar to separate the trial. Student 1, 2, 3, vertical bar. Student 1, 2, 3, vertical bar. So there's my completed. I don't need the rest of this because the question didn't ask me for the rest of that. So how many completed it in trial 1? 3 out of 4. Trial 2, 2 out of 4. Trial 3, 3 out of 4. Based on these trials, the probability of getting 2 or fewer completed assignments is 1 out of 3. Ta-da! And that's it. So if you need more practice, here's the unit exam. Of course, at this point, you can read through the chapter or you can go through the 3 assignments, blah, blah, blah. See you in the next video.